Hey everyone, my name is Josh, and this is Moonlight. As a quick intro to Moonlight, if you haven't been here before, what we are is a place for creators at 42. So whether you're working on a side project, a game, an open source tool, or whatever it is, we're a place you can come talk about it and get some feedback. And so each week, the meeting is divided into two parts. The first part is a kind of an open mic. Anyone can come talk about something they're passionate about, get some quick feedback on a project want to do, whatever. You have 5 minutes, including Q&A, to get that feedback. In the second part of each meeting, we have a demo. This is about a 15-minute demo where you can hook a computer up and show people something you've made. And this week we have Oleg, who's presenting on his macros and how to use them as both kind of the equivalent of lambdas and calculus, as well as a way to get around norm. So that's today's demo. So let's get started on the first part. Does anyone have anything they want to talk about? Any side projects you're working on? Awesome.
Hello, I'm Sean, and I want to ask you all if you like karaoke. Nice. What about if you could play karaoke in a car on a long road trip with your friends? Sound like fun? All right, that's why I'm presenting karaoke. My idea for a karaoke phone app that you can use to sync up with your car's Bluetooth and play your songs through your radio, the background music through your radio. You'd have the lyrics on your phone, and you could play karaoke in the car. And that's about it. That's like just the idea. And I was gonna see if you guys, yeah, sure.
Question about that.
Uh-huh.
Had a similar discussion with a previous game where we said, oh, it'd be cool for the car.
Uh-huh.
This involves reading. How would the driver
The driver would listen to the songs. The driver would not play by himself or herself on a long road. They would listen to music normally. But if there's more than just one person in the car, yes. The driver cannot play Pokemon Go. Pokemon Go does not does not promote that. Yeah.
What if the passengers in the backseat aren't buckled?
Then if they're in California, that's against the law, and they will get pulled over immediately.
All right. The other question I would have for that is, how would you deal with copyright?
The question is, how would I deal with copyright for making a karaoke app? I'm not sure what copyright you'd have to deal with. I don't know if the name CAR, C-A-R, karaoke is taken, but music-wise, I would go for some nice, what's it called? The free music that is not copyrighted by everyone. At the beginning, maybe you can make a deal with people who have a lot of music. What's up?
DeVry left a lot of karaoke.
He sure did. I could absolutely rip those. Yeah.
I've been to a couple of parties where we had karaoke machines for Russian music.
Mm-hmm.
All copyrighted. They weren't exact songs. They were just close. They were compared to melody. You wouldn't be able to tell unless you listen side by side the track, not the same, and then you just sing on top of it.
That's perfect.
I'm pretty sure that's what every karaoke machine does.
Really? Oh, they just like kind of closely change it a little bit.
Unless they pay the licensing fee, which most of them I feel like don't.
Yeah.
Like Russian karaoke.
Yeah. Yeah, we could get around that. Any other questions? You guys think it's a good idea? For like 15 minutes, yeah. For road trips.
I mean, think of all the different car games people play on road trips.
Yeah. All right.
Especially if it was like the first part of a suite of car games. Karaoke does feel like that very well.
Yeah. Oh, that's actually a really good idea for all those people that drive around all the time. Really?
Thank you.
Jack Fox for Uber drivers.
I actually had an Uber driver that had karaoke.
That's awesome.
That'd be awesome. Awesome. Does anyone else have any side projects they want to talk about? Anything they're working on? All right, no one else? Last call? All right, Renee.
Sup, everybody? It's me again. Everybody knows me already by now. My name's Renee. Cool, quick, awesome update. Well, it's an update, kind of really cool thing that happened over the weekend. So, yes, just wait. This is for Fridays. Since we didn't have DJ Club last week, we're gonna have it this week. And I got cool news for my DJs. I met DJ Qbert, and he actually sent me some whatchamacallit, small classes that he has a DJ school. So, well, he's in the courses of sending me stuff for DJ Club. So it might be cool. Maybe we get those sometimes this week. And, keep improving DJ Club. If anyone's down, coming down. Huh? Friday is from 5 to 7. Oh. That sucks.
Have you thought about kind of combining 42 aspect and making some custom software for DJ Club?
Yes, and we've actually discussed how to integrate 42 and the DJ Club. So primarily, one of the biggest things DJs use are sound effects, to make their actual playlist, really cool. So since we have a lot of open tech here, I've used Arduinos to mess around with sound and like motion sensors and like depth detectors, and just adding sound effects to that. So converting that input into like a MIDI output and messing with the effects once a song is playing. So like you go up and down, and like the filter goes up and down. So those are some of the things that we want to implement. So right now I just want to train people into just getting used to like mixing music, and then slowly we're going to start implementing more stuff in the very, very near future. But yeah,
Do-it-yourself controllers like Set-Go?
yes. So making our own controllers, so like do-it-yourself controllers, it's probably one of the coolest things that I do have in mind for that, because controllers out there are super expensive. Yeah, they start somewhere between $200 and above, and then if we get just a small crappy, yeah. So like a small Arduino that we could just mess around with could just get us $60, and we could just mess around completely with it. So it'd be really, really nice to see what we do. But yeah, anyone else? All right, pass it back to Josh.
Awesome. All right, we can go ahead and get started on the demo. Do you want to go ahead and get setting up Oleg? And so what Oleg is doing is kind of introducing how he uses macros this week. So it's a really cool presentation, as well as want to get a bit of a demonstration. So are you ready?
Hello. Okay, so discussing C macros a little bit. I think they get a little bit of a bad rap. They are a really useful part of language, and they are part of language, so let's take a look at a few things we can do with them. So the motivation is, like occasionally when I do a correction, I'd be like, oh, you have a memory leak here, and I see this all the time. And for me, I'm like, I have a macro that never lets this happen. And it's the leak where you malloc a couple of pointers, and then like after you malloc it, you check if it was null and you return null. I have an example later. The first pointer never got freed, so you actually leak memory. And you can also reduce code noise, so if you have a bunch of branching logic in a function that isn't really about memory allocation, you don't want to see that. It's really distracting to somebody reading your code or to you reading it later. And even when you're just writing the function, it's very distracting. You can reduce the amount of branches in your code really easily to do something like I would consider boilerplate. Like it turns it into a concept, as I'll show later. And of course, what we're doing to solve this is literal text search and replacement at compile time. So there's no runtime overhead to any of this. And so you can turn your boilerplate code that you write over and over and over, you can actually turn it into an idiom that you're going to use throughout the rest of your library or program, and it'll be reusable and instantly recognizable. And it'll represent a concept and an idea rather than like actual pointer manipulation. So here's the example I was talking about. I mean, you have to do this all the time. We have to check our returns from malloc. So all we're doing is allocating for 2 pointers. Like, let's say we allocate the first pointer, ... we do a little bit of work. And if either of these allocations fail, you know, we just dip out of the function, right? If we couldn't allocate memory for our function to work with, we can't do anything in the function. But what happens if the first allocation succeeds and the second one fails? We would have actually had to have freed the first pointer. And this is a slightly contrived example because in practice, malloc isn't going to fail. But there's going to be times when you have a function that will replace malloc that does your allocation for you, and you pass in a couple of variables, maybe a couple of flags, and that realistically can fail all the time. I think, yeah, the other day I was actually correcting Minishell, and the person I was correcting, he was pretty confident he didn't have any memory leaks, and we just happened to run it through leaks in such a way that it did hit a case like this. And I was like, well, let me grep your mallocs. And as soon as I saw this, I was like, oh, I know what this is. Like, we can fix this in a few seconds. So it's not that contrived an example. I've actually seen it happen at least 2 cases in 2 corrections, and in my own code all the time. I just think it's really frustrating to riddle a function that's not related to memory management with memory management, right? So we can do better. It's a lot cleaner to write a macro that you pass the names of all of your pointers to after you allocate them. And if any of them were null, and you can pass as many as you like, you can pass between 1 and 63. And I'd be interested to see anyone pass up to 63 pointers to it. I think we're capped at like 4 function parameters and 5 local variables, right? So up to 9. So I just kind of went overkill to make sure there'd be no need for any more. And so comparing this to the previous code, right? We can see that there's less branching. We have a concept instead of like actually having to read this with our eyes and make sense of it. So it's conceptually based code. I feel like it's maybe not the best word to use there. Not anything to do with concepts as a language feature of other languages. Sticking to C here. And of course, there's no memory leak, which is the most important part. So it like precludes the possibility of an error happening in the first place, and it cleans up your code. So how do we do this? Well, if anyone knows a little bit about Turing machines or lambda calculus, Turing machines are the smallest machine that can possibly compute any programming problem. Lambda calculus is a software analog of that. It's the smallest possible programming language that can represent the logic necessary to compute any programming problem. Pardon me. And turns out that C macros are actually pretty much lambda calculus. They have extra rules on top that are a little bit annoying, but not so bad. And they can actually achieve all of what lambda calculus achieves. You can solve any problem with just macros. I wouldn't recommend it, but we can pretty easily implement some really useful language features. And some very talented individuals have done some really substantial work on this, notably in Boost PP and Paul Foltz's tick library. And Paul Foltz especially is like crazy because he's messing with macros and templates together. That gets really interesting. So there's a lot of like work that is not only overly complex, but also not norm compliant. So I tasked myself with implementing a few things differently to both be simpler and also to pass the norm. Okay, so macro basics. It's text, search, and replacement. There's 2 kinds of macros, object-like and function-like. I can show you guys real quick, actually. Oh, typing and talking is going to be interesting. Oh, I shouldn't alt tab. Let's see. Oh, it'll be fine.
So the syntax is actually really simple. An object-like macro just does search and replace and nothing else. A function-like macro, you can actually pass parameters to it, and they're going to replace any of their occurrences inside of the expansion. So like, you can just have param here. Thank you. Mm-hmm. There we go. Cool, thank you. So that's it for the syntax for that, but we have a few more features. Let's see. We can actually pass any amount of arguments to our macros that are function-like by using an ellipsis like this. And then we can use that just like a parameter where it just puts them all in sequence, comma separated, using this thing, underscore underscore, VA underscore args underscore underscore. Kind of verbose, but you get used to it. And we have two more features, the hash guys. These are used for stuff like this. Pstra is just going to take X and turn it into a string literal, which is handy sometimes. And if you want to use this with a macro, you can actually do this. So yeah, macros call on macros, get used to it. So like str of, I don't know, some other macro, like we have one called object-like. What this expands to is going to be object-like. Or no, sorry, expansion. Yeah. Which is handy sometimes, but anyway, slight tangent there. And the double hash, a bit more useful. Gonna have a pcat and a cat. Gonna take a X, call it. So this will allow us to concatenate two tokens together into one. And the indirection here of cat and pcat and stra and pstra is necessary because otherwise, if we just used pstra immediately, the macro wouldn't have time to expand and it would actually expand to this. And sometimes you actually want this behavior anyways, like they're both useful. These are macros, no semicolons. Anyways. Oh, I didn't really explain that one. Hold on. So, like, well, pcat and cat are actually going to end up doing the same thing. It's just you have to be a little bit aware of when to use one or the other. But like cat of A, B, C, D, E, F is going to expand to A, B, C, D, E, F. And you can see the power of this pretty clearly and immediately if you have like do something. And maybe you have like a couple of varieties of do something that you defined, and you give it a number. This will expand to do something 1. And now you can start to get a sense of how, let's say you have a bunch of macros, you know, do something 1 through like 5 or through 63. You can start to see how you can start to use that to get some useful features out of macros, which I'll show you in a sec. Maybe we shouldn't, okay. Before we jump into Argon, I'm actually going to go to macros FD and show you a little bit of that. So this is the header file I made. I'll zoom in here. Oh, I'm not sure how to zoom. Oh, there we go. It's just delayed. Is that big enough for you guys to see, or should I zoom more? I'll zoom a little more. So here's that token the token combining I was talking about, that hash operator. And it turns out that the factorial grows so fast that you only need a couple of macros to actually define it, all of them, so that you can store in C. Because factorial 19 actually wouldn't fit in anything in C anymore. It wouldn't fit into a unsigned long. So we write a function like macro fac that takes n, and we token paste it with n, which expands to an object like macro, and that just expands to the number. And we're going to need to put an expand around that actually, because it's going to expand once, and then it's going to be out of macro calls, so it's just going to finish off at fac 0, so it'll just expand to fac 0, and you can write a simple macro called expand that just expands it one more step. I had actually neglected to do that, but it's pretty simple. The exp macro is somewhere down here. Here's the same thing for pow. Again, it would need exp parentheses around it in order to expand completely. And yeah, so the idea of this was how much can we actually represent? Well, power of 63 to the power of 63. That's about as big as numbers get. Not quite that simple, but pretty close. And there's the expand macro. As you can see, it just does a ton of macro expansions on whatever you give it to make sure everything completely expands. So yeah, I don't even know how many scans this gives, but it's a lot. I think it's close to 1,500. And with that, those are some basic ways to use macros to get yourself a little bit of function overloading feeling, at least with the number of things you pass. Now we're really in the meat and potatoes of it, and I'm going to go back to slide for a sec. So this is how we want a macro that's going to count the amount of things we gave it, and this macro is going to take that ellipsis format, or that ellipsis argument, ... that varargs thing. So any amount of stuff, and we're going to count how much it was, and we're going to expand to it, and that'll let us do what we did kind of with the factorial, but instead of passing it the size this time, we're passing it a number of arguments. So we're going to do something very similar. And we're also going to generalize this and make a macro that does this for us actually, which is going to be called vmac. And this can give you parameter overloading and default parameters in C if you would like it, but also you can implement higher level things like checkalloc, which we'll get to. And we're going to achieve this by passing arguments and a reverse sequence from 63 to 0 to another macro which has a sequence of arguments, placeholder arguments, _1 through _63. And this will actually expand to give us the number we want. So you can see the reverse sequence here. All this macro expands to is literally comma-separated numbers from 63 down to 0. It's meant to be passed into param seq 63. If you pass it directly in, it's going to fill out, 63 through 1 is going to fill out 1 through 63. And you're going to be expanding to num at the very end. And num is going to be 0 in this case. But if we passed in one more argument, which in our case is going to be the arguments to our actual function, let's say we give it 4 arguments. _1 through 4 are going to be eaten up by those arguments. And then _5 through 63 are going to be eaten up by 63 through 5. And then num is going to be 4. And we also have an ellipsis at the end to catch the 3, 2, 1, 0. And the expansion at the end is just num. So that'll give us 4. So voila, we've counted the arguments we've passed to a macro. And we can use that in conjunction with cat. and a little bit of what's up? Fine, okay. A little bit of macro splicing. So at the end there, you can see parentheses, VARgs, parentheses. This actually isn't a macro, but the thing about macros is that you can actually just splice tokens as you wish, and as long as it expands to something at the very end, it's valid. So you can do some pretty heinous stuff with that, but we're using it pretty cleanly here. You can even like steal parentheses from a macro call and like make it expand into something else, which is, I mean, for a future Moonlight, but I have done that in the past. So we concatenate f, which is the name of our function or macro. This works with C-style functions, by the way. You don't have to define functions. You don't have to define macros. You can define functions labeled 1 through 63, and calling this macro, which can be written in lowercase, will expand to 1 through 63. So, and you can even mix. I wouldn't exactly recommend it, but you can mix it. It can expand to a macro or a function. So, you know, we're just going to concatenate f, like with the hash example before, with what argn gives us. And argn is the number of arguments. And let's say f is min. Min is a very simple idea. You give it a list of numbers, and it figures out which one is the smallest. And it takes up to 63 parameters. It does ternaries to achieve this. And it calls previous definitions of itself to avoid going over the 80 character limit. Oh yeah, I should have talked about that. All norm-compliant macros must be 80 characters or less, which is tricky, as you can see. But there's some not so ugly ways to get it to actually achieve that, which I found surprisingly, and I was happy about that. And once that expands, we have that you know, kind of stray set of tokens there, the parentheses, VARgs, parentheses. And so f hash 4, let's say we had 4 like before, min hash 4 is going to be min 4, and then it'll take those parentheses and just staple it on it, so we get min 4 VARgs. So we just pass our 4 arguments into min 4, and it'll work. And that's kind of like a contrived example, although it is like a staple. I did max as well. A little more useful is making an infix operator, because then we can do some logical macros. The first one's a dummy just because of it takes an operator, so it starts at 2 instead of 1. So, but it doesn't really matter. We use the v macro again. OP is our operator. Infix is the name of all of our macros minus the number tacked on, and we're going to pass it VARgs again. So let's see where we use that real quick. Yeah, so or and do all use infix op to allow you to put ors and ands between any list of parameters that you give it. And we're going to use that in checkalloc. And also do is necessary for being able to perform a series of actions, which we're also going to use for checkalloc by making an if statement. These are some macro hacks, which we'll get into if we have time, for getting around norm. So at a glance there, you can do nested ternaries, you can use switch statements, cases, do whiles, fors, assembly go-tos, and normal go-tos, you know, whatever your heart may desire. That's just there for fun. It was pretty quick to whip that up. And so the kind of that boilerplate-ish macro code, some of it can be condensed, but I just haven't gotten to it yet. This is where the actual code is, like the essence of it is. And you can see it's actually pretty short. Looking at null check, we return null if putting ands between all of our all of our arguments and take the not of it. Okay, I mean, you do this at the top of your functions all the time, right? Like, if any of the pointers passed in were null, return null. That's all it does. And it just expands that exact code. And checkalloc, there's a checkalloc 2, which it calls just because of the 80 character limit. It does something very similar, but it does a little bit of extra work. It just frees all of the arguments you gave it, and then returns null. So basically, if any of your mallocs return null, it's going to free all of them. And freeing null is actually no problemo, perfectly fine in every modern compiler. You'd have to go back to some like really old Palm OS stuff for that not to be the case from like, I don't know, 2000. And yeah, that's checkalloc and how it's implemented. And oh, I kind of forgot about the slides, got a little carried away there. But yeah, this allows you to just use one line of code to do something like this. And I probably should have like put a null check example, but it's pretty trivial. You just literally put in your pointers that you don't want to be null at the top of your function. And as for what's next, Paul Foltz has a pretty cool thing called Cloak, where he implements a lot of these constructs purely in macros. So the way I did it, actually, it uses C runtime code, actual C code, to do this, because that's what we need for it to work. It actually won't work at compile time because it's runtime checking. So, but if I did that, I could get rid of like those sprawling 1 through 63 things. I could just use a loop, a macro loop, to generate those macros for me. So macros generating macros, further consolidation of ideas, victory. And I was also thinking, like, it's a little bit contrived to just deal with pointers. Like, maybe we have a struct, and maybe we want to make sure none of its pointers are null. And in that case, we'd also need to be probing its types. Like, we don't want to check if an integer is null. That's not very useful. And probably the best way to do this would be to implement tuples, which are actually very simple in macros. They're literally just parentheses separated comma pairs. And also, the only feature I missed from C++, from the little bit of C++ I've done, is reference counted pointers. So that's the dream right there. And that's that. If anyone has any questions or wants to, I'll show you guys the norm hacks really quick, actually. Just a quick, hold it. Patience. I don't know how to exit full screen. Wait, yes I do, okay. I'm not that silly. Yeah. Don't mind the Star Wars text. So this is some of the obscene stuff you can do with this, just for fun. F is a function that ate up 23 lines of logic mysteriously and wanted more. So it uses an assembly goto to jump into the scope of an F extra space function, do some more logic, notably A equals 5, jump back to the original function so that it can return A. Essentially, allowing you to, in the most convoluted and most useless way imaginable, bypass the 25 line per function limit. Take that, Norm. This is just like, I kind of had to do this for all the suffering the Norm caused me, right? Getting used to it. It's like a little payback. Var lets you declare and initialize a variable anywhere in scope. So that's saying int a equals 0. You can see that's a switch statement. Oh, can you see? Oh my god, you can't see anything. I'm sorry. Now you can see. And nested ternaries, declaring your variables anywhere you want. Gotos. For loops. The loop is a for loop with like for semicolon to loop infinitely, but also the normal for loop works. So that's just for fun, really. But yeah, if you ever wanted to really stick it to the norm, or you really, really want to shorten your function because you don't want to write another, you can use these to shorten your code a lot. But it's mostly just there as a gag. That's it. Question?
So, do you use Emacs?
I do.
Emacs has a C macro expander.
I know.
What does that code look like when you expand it?
It's got no new lines. It's just like a bunch of lines that are like really long, 200, 300 characters. Well, norm, all this stuff passes norm, obviously, because norm checks the source code, not, the compiler, precompiled macro expansions. So yeah. But personally, I think it really cleans up code, and I made my points, so yeah. How should I close up here? Just walk off, or anything you want me to do?
right. Thank you, everyone, for coming to Moonlight. As always, if you want to present at Moonlight or demo ever, either come talk to me. Or there's also a Google form that's now pinned to the Moonlight channel, so you can just find that and fill that out as well. Thank you.